Okay, now that we imported the sprites, let's understand how we work with sprites. So as I said, the sprites are basically an image, a rectangular image that you can bring as a game asset to your game level. So I loaded a few sprites here from OpenGameArt. So let's say, like for instance, these asteroids. I don't think you have these same ones. You can use other ones if you like. So in this example here, we have a bunch of individual sprites for asteroids. If you select one asteroid, you can basically drag and drop into your game, and it's going to be a 2D image as in your project. You see, it's going to use the same name as the file. You can actually come here, the inspector, and rename it to asteroid dash large. In the inspector, one parameter that's really important you to pay attention is called pixel per unit. That's basically the relation on how many pixels of the sprite are going to be rendered every unit in the Unity environment. You see this grid here at the bottom, that's one Unity unit. So basically right now we have 100 pixels being rendered per unit. So if I change this number, let's say to 30, and then hit apply, what we are going to say that every 30 pixels in my object is going to represent one Unity unit. And so my object is going to look much larger. If instead of 100 I go 200, so I make it a tiny object, because I basically in one unit I have 200 pixels. The default is 100, so for a sprite based game that's okay to keep this way. Later, when we start creating other types of game, top down and so on, we are going to have to check that with more care. Other than have single sprite representing a single image on the screen, I can have an animated sprite. And basically what we do for an animated sprite, we need to have each frame of the animation saved as a separate file, and then I'm going to play one by one in sequence after a certain amount of time to play the entire animation. That's exactly what I have here. This asteroid, as you can see here, we have frame by frame as a separate file for 16 in total. So starting from 1000 to 10015. So 16 frames at total, and I want to make this into an animation. There are different ways of creating an animation in Unity. Let me show you the most common ones. The easiest you can do to rapidly create an animation, you just go here in the project, you select all frames holding shift, and then you just drag and drop to your environment. Unity is going to ask a place to save the animation, because Unity already detected that you are loading multiple frames at once. So what I'm going to do here, I'm going to my assets folder, right click, and create a new folder for animated sprites. We have one for sprites, now one for animated sprites, and let's call this asteroid large and save. And notice that we still cannot see the animation because we need to play the game for that. So let's play the game. And there you go. We have this animation running in a loop. By default, it's going to play in a loop all the time. The thing, a few things you need to remember when you are doing this approach of drag and drop all the frames to your game environment. First, we are going to use all the parameters for your animation set by Unity using the default values. So you don't have control over, for instance, the frame rate. If you want to add more frames to your animation, invert the order of your animation, whatever it is, you are basically accepting the default values in Unity. A much more professional way would be to use the Unity animation editor and create the animation by hand. Let me show you how you do that. First, we need to have an object, so I'll add just the first frame, just for us to have a game object on the screen. And with that game object selected, I will create an animation and associate the animation to this object. What I'm going to do, I'm going to open here Window, Animation, and then the first option, Animation, the shortcut is Ctrl+6. You have the new editor for the animation. What I want to do, I want to dock here this at the bottom. You want to have the possibility of seeing the project and the animation tab side by side, because what we are going to do, we are going back here to our frames, and we are going to drag and drop the frames onto the animation tab. So with my object selected, again, let's change this to asteroid large. I don't like to use this name 001, it's counterintuitive. Okay, now we have one object. We have this button, create animation. So I just click this option. I'll save an animation. I will override the other animation just created, so asteroid large. It's asked for me to replace it. I will say yes. If you want, you can create a new one. And now we have the animation editor ready to accept new animations. In 2D, that means to bring frames into this editor so you can save. In 3D, would be to interpolate in between certain position, rotation, certain attributes on the screen that you want to see changes over time. So right now, what I'm going to do, I'm going to hit this red button to start recording. Everything is going to start red. And then I bring the frames I want. I could bring one by one if I want to specifically place each frame on a specific timing, but it's much easier to bring them all and then work with them in the editor later. So select them all, drag and drop into here, and we already see what I mentioned before. We use the default. Unity is going to use a very short distance between each frame. Right now I'm looking the editor, the animation editor, using seconds. So you have here a fraction of a second. The entire animation would last 0.15 of a second, so 15 milliseconds. If you want to see this in frames, you can open this option. Instead of seconds, you change to frames. So you have 15 frames, each frame 1/15 of a second, and that's what makes the animation run really fast. You don't want that animation running this fast because it does not make any sense. So to control this, we need to have the samples of your animation active. If you are not seeing this option, you come here to the ellipse button and you have show sample rate. So it might be hidden in your case. So you just here show sample rate, and then you have how many samples you want to render every second of animation. Right now it's 60 frames. So we have an animation that's only 15 frames. That's why it's rendering so fast. Let me put 15 samples so I know that my entire animation is going to last 1 second. I have 15 frames, 15 seconds. So if I play now, I have a much smaller, a much slower animation this way. You also, if you want, I could select the frame by frame and invert the order. So if I want this asteroid to rotate in the other direction, I basically select each frame. You can, by selecting a frame, you just click on the frame and then you drag and drop to the other side. It would have a possibility to render the animation in reverse, and this way you would have the asteroid spinning in the other direction. I'll keep mine in this way. I'm satisfied with this animation, so I just stop recording the simulation. If you want to add more animations to the same component, for this asteroid doesn't make any sense, but in the future, when you are creating characters, will make sense. We can come here in this drop down menu and create a new clip. This clip is going to allow you to add more animations, associate more animations to the same object. And the way Unity controls this is by using another script. Right now we have, if you check here, Unity already created for you this script called Animator. And Animator is just a manager of multiple animations associated to the same object. For you to be able to visualize that, we need yet another editor. So go back to Window, Animation, and then you have the Animator. Right now it's docked here at the top, and if I'm docked there, I cannot see the scene and the animator, so I will undock and dock here at the bottom. So now we have let me move this a little bit. So now we have the Animator tab, and we have the possibility of looking at my animations. The way the Animator works is to create a finite state machine. Basically, we have a bunch of states, these rectangles here, and each state represents one possible animation, and then we have transitions. Transitions are those arrows that connect one state to the next. We'll be able to create multiple animations to a specific game component, and then create transitions to tell when we want to go from one animation to the next. A simple example, we have a character that is capable of running, jumping, dying, shooting, etc. Each one of these would be a separate animation with its own sequence of frames. It's going to be a different state here in the state machine, and then you create a transition when the character is supposed to run, when the character is supposed to shoot, when the character is supposed to die. We are going to have a criteria that we are going to change via coding to decide what animation to play in every single time. We are going to circle back to this later. Right now I just need you guys to understand how to create these animations. Okay? One last thing about sprites is that not always we are going to get every single frame of the animation in an individual file. Most of the time artists will prefer to create a sprite sheet like this one. So you store all the frames of the animation in a single file. So Unity will have the later to split this file into individual animations before we start to be able to use them. So let me show you how you guys do that in Unity. So you have here the file. If you go to GFX folder, you have the character, and the character we have a bunch of predefined sets. First thing I changed is to make this into a sprite. By default, Unity is going to use this sprite sheet as a single sprite. So you have sprite mode single. You want to come here and change it to multiple. You can change pixels per unit if you think your sprite sheet is too small or too large. We are going to circle. For now, let's keep it this way. What else we need to change? We are talking about pixel art, so probably a good idea not to use any anti-aliasing to make your image look blurred. So what I'm going to do here is to use point filter. That means no filter at all. So our image is going to look the way the artists draw the pixels in the sprite sheet. That's the way you are going to be using. Same thing go for compression. We don't want to use compression, so to increase the quality of your animation. Also increase the speed on how Unity is going to process this image. So you hit apply. After you hit apply, we are ready to start splitting this sprite sheet into individual sprites. For that, Unity uses an editor called the Sprite Editor. So if I click this option, we have here the Sprite Editor, and notice the checkers background that tells me that this entire sprite sheet has a transparency. In the background is completely transparent. So for you to split the sprite, we have several ways of doing that. One way is to manually select and drawing a rectangle, and you are going to create a sprite. You have here the parameters for that sprite, so you can place this anywhere you want. You can change the size, adjust to a very specific rectangle around a character. This is only useful if your sprite have a weird shape and weird positioning in the sprite sheet. It all depends on the quality of the artist to actually create sprites in a way that's easier to split them apart later. Most of the time, artists will create sprites at a constant distance, vertically and horizontally, what makes the process of splitting them in individual styles much easier because you can automate the process. That was not the case for this example here. Unfortunately, the artist who created this sprite sheet did not follow a constant pattern. We have for the first sprites here, we have a pattern for these 16 sprites and these ones and this one here. We have a pattern, but for the other ones, it's a completely different tile size. So what I'm going to do, I'm going to use an automatic sprite sheet. I use an automatic criteria to split the sprite, and knowing that this criteria is not working for every single sprite. For me to slice sprites, we have this slice button, and in this slice button you have different types. Automatic means you are allowing Unity to guess which sprite is individual sprite. In this particular example here, it might not work well because if you can see here, the sprites are touching each other, and Unity will understand this as a single sprite rather than individual ones. I can try to slice. See what I told you? You create a single sprite here because Unity did not understand these are 4 tiles, but instead it thought it was just a single sprite because it has a continual set of pixels. So automatic might not be a good idea for this example. Let's try something else. We had other possibilities to separate by grid by cell size. If you know how the size of your tiles, you can use this. And particularly I know for this top part here, the artist is using 16 by 32 pixels. You can see the red grid that's going to be used for splitting the sprite, and you notice that for this 16 here on top, and also this one here, and also this one here, they got it right, but it start to fail with this other sprite and this other here at the bottom, which means that we would have to readjust the splitting for these styles later if we were to use this entire sprite sheet in the game. But still a good idea because it got most of them right, so it helped a lot. If the art is good, the artist will design the sprite sheet to be in a grid, so you can actually split it automatically. The other options you can use by cell count. So if I know that I have 15 by 20 sprites in a sprite sheet, I can use that. It doesn't matter the size of the sprites. And finally, for isometric grid, you would use diamond shape sprites to extract them. We'll circle back in another video for those examples. For this one, I will agree it's done. I will click slice, and then finally I will click apply. So this way Unity is going to be creating individual files for each sprite. Another thing to notice in this example is that the Unity is going to use the name of the file and a suffix, so character underscore 0, underscore 1, underscore 2, underscore 3, and so on for each individual sprite it was created from this sprite sheet. Simplifies our lives because we don't have to name it each one, but later we are going to have a sprite sheet composed of dozens or hundreds or even thousands of sprites, and if everything one of them is just numbered the same, named and using the same convention character, it's really hard to know what character 34 means in the code if you are not properly naming them. So probably a good idea is to, at least for a smaller sprite sheet, is to want to select them and rename. We could have here character run down 0 and run down 1, and so on for the others, if you want to have a more intuitive way of naming the sprites. I'm not going to do this right now, but you are going to see that later when I'm using this sprite sheet. It makes our life really hard to remember which sprite is what in the game environment. So let me hit apply one more time, and let me close this editor, and now we are back here in the Unity editor. If you notice, next to my sprite sheet, now I get this arrow. If I click the arrow, I'm going to get that's the thing about Unity. Sometimes you get a thumbnail for the sprites, so simplifies our life, but I don't know why it doesn't work every time. So in other cases, you are going to get a purple rectangle rather than the actual sprite. Might be something related with graphics card or the number of sprites in the sprite sheet. I'm not sure why that's not really reliable every single time, because it's really helpful. Now I know that if I want to create a character walking down, I select these 4 first sprites, and just like before, I can drag and drop into my game, create a file. So go back to my assets, animate sprites. Let's call this walk down and save. And notice that how tiny this sprite is. That's because it's using 100 pixels per unit. This way the character is really tiny. So to fix that, select the character. Let's go. I know, as I said, I know these tiles were created 16 by 32. So horizontally, I know they have 16 pixels. So if I change here to 16 and hit apply, we are going to get a character that occupies 1 Unity unit. So like so. It will not match vertically because vertically is 32, so you would use 2 vertical. You can see by the square now. Use 1 unit horizontally and 2 units vertically. And if I play my game now, you are going to see the character is running really fast. And because I have the character selected, if you check here the animator, you can see that particular state is running over that. The first state you always create is going to show in orange. That's the state, we call this the default state. If you have multiple states, only the first one is going to be orange, all the others are going to be in gray, and you have to create a transition between the states. If I want to fix this in this animation, I still can go back. Even if I created the animation with drag and drop, I can go back with my character selected. I didn't rename the character. We could call this like player, assuming this would be the player for my game. You can come back here to animations. You see the walking down animation is showing right here, and we have a 12 samples per second. So if I go to recording and change this to a different number, right now we have only 4 frames. So let's go for maybe 4 samples per 4 samples per second might be too slow, but we can play. Yeah, I think it's way too slow. Maybe we can try 6. Enter. Yeah, I think 6 is better. And we have now an animation playing the animation character down. Just before I let you guys go, I wanted to illustrate how it's going to look like in the animator when you have more than one animation. So still with my player selected, I go here into animation tab, and I'm going to create a second animation. We already have walking down, so let's create a new clip. Let's call this walk up. And for the walk up animation, I select the 4 frames, like this one until this one. I think I'm selecting right. Drag and drop in here, change this to frame 6, and if I play the animation, there you go, we have the character walking up, we have the character walking down. We could create all 4 directions, the up, down, left and right. And if you see the animator now, we have 2 animations, walking down and walking up. Because the walking down is orange, when I play this game, the walking down animation, that's the one is going to be played. And there is no way for me to change from walk down to walk up. For me to do that, what I need to do is to create a transition. So I select the orange frame, the orange state, and then I can make transition, and I go to walk up. And now I have a criteria that is going to tell when I should move from walking down to walk up, and I can have also a transition from walk up back to walk down. Right now I don't have a criteria between the two. Let's create a parameter real quick. Could be like a boolean variable, and the boolean variable could be whatever name you want. Walk up. So in the transition that goes towards walk up, what I'm going to add here a list of conditions, and walk up is true, so it means that I'm going to move from walk down to walk up. I don't need exit time. Exit time means that I will wait until the animation to complete before changing state. If I set this if I uncheck this option, I immediately move from one state to another as soon as the parameter changes value. And one last thing, because this is an animation based on pixels, I don't need to make a transition between there is no interpolation between pixels. So this is useful for 3D animations but not for 2D. So transition duration I will set to 0. So I basically snap for the end of one animation, I snap to the next animation, and I'm going to repeat the process in the other direction. So if I'm walking up and the state to walk up is now false, and then exit time is not checked, duration is also set to 0. Now I have a condition that can switch back and forth between walk down and walk up based on the value of this parameter. Let me play the animation. See, we are playing walking down, and as soon as I check this option, we start playing walk up, and if I uncheck this option, we are back to walk down. And we could do naturally, we would do down, up, left and right, and we would be changing these flags using code to based on inputs from the user. But see what we are going with this, we can actually start programming the behavior of our sprites in our game.